Good evening, everyone. This is Vikash Srivastava, founder and CTO at AlmaBetter. So I hope you all are having a great day. First things first. So guys, can you please turn off your video and also mute yourself? Okay. Uh, yeah, that's perfect. Okay, so please turn off your video. All right. Uh, so again, yeah, welcome to this class. So this is the first class of the our data science program, right? So uh, we have divided our curriculum into 8 modules. So and the first 7 modules, they are theory oriented, as in we'll be covering all the relevant data science concepts. The first module is your Python for data science. The second is your maths for data science. The third is supervised machine learning. Fourth is unsupervised machine learning. Fifth is then deep learning and NLP. Sixth is your ML and data engineering. And in the seventh, we'll be discussing about popular analytics tools such as Excel, Tableau, and Power BI. And the last month is, of course, dedicated towards placement preparation, which is part of our AlmaX program, right? So I hope you're all excited, right? So you're about to embark on a new journey, right? So you all are very passionate and motivated guys, and I really hope you stick with the program as the classes go on, right? So we'll be learning a lot of new stuff over the course of next few months, and I hope you'll have a fantastic journey ahead, right? So today we'll start with the first lecture, which is uh, discussing about Python fundamentals. So in Python fundamentals, we'll be talking about basic data types which we can encounter in Python, right? And so before we actually deep dive into the lecture, which is integers, floats, and Booleans, I just want to engage you a bit in an I just want to know what's your current understanding of Python. So I'm sharing a link with you guys. Okay, uh, so can you please open this link, and I'll ask you a bunch of questions. So can you please just post your answer on this here? So I have sent right. So just open this link in your browser. Okay, and if you want to just so whatever questions I'll be asking, so you can just double click on the screen and you can post. Okay, so that's how we'll be keeping the things, try to engage you more. Okay, so let's start with the first question. So why do you think Python is such an important language, or just tell me what are the advantages of the Python language? So can you guys please post your answer here? Yeah. So I request everyone to just engage here, right? So write the answers in a very short, crisp manner, right? And also uh, put your name, right? So I hope you have all created the Padlet account, right? So I'm getting few answers here. So Rohan is saying that large community support, right? And then someone is saying open source. I I request especially the guys who are enrolled in the premium program, please uh, answer this by logging into your account. Okay, so I know which one of you is answering this question. Okay, so Gaurav Bhagat is saying that large libraries. All right. Then we have open source, right? And right, so there are a lot of answers popping up here. So Python is important to know the internal factor of data. Okay. So simple and easy can handle data and object oriented. All right. So okay. So large community support, which is really a great point, right? So Python is currently has the largest open source community, right? So that's why the development in Python has been so staggering, right? So over the course of the last 20 years, Python has been, has taken a tremendous pace, and it's growing day by day. So a lot of developers, a lot of Python enthusiasts, they're contributing to this community, and that's why we are seeing huge surge of demand in Python related skills. If you scan across the opportunities available, especially in the field of data science, so almost all the companies, they require you to have this understanding of Python. Of course, There are other languages which are used for data science and analytics, such as R. R also has a good base of good user base, but Python seems to be the forerunner, right? So I'm getting a lot of answers here. So maybe I can. So easy to learn, speed and efficiency. So Sriram is saying, which is pretty correct, right? So it's a very intuitive language. It's easy to learn. So the syntaxes are pretty easy to comprehend, right? And let's look at other answers. So used in AI and ML, which is in fact right. So we have a tremendous support of machine learning libraries, statistics libraries, and then of course you know about deep learning frameworks, right? So a lot of new libraries are there in Python for all the tasks which we can do related to machine learning and data science, right? So Python is the go-to playground for all these such activities, what we want to do, right? So let's say if you want to build a machine learning model, of course, if you don't know these terms, right, or might have just heard of them before or just hearing them now, you don't have to worry, right? So we'll be, as will be progressing through the course, all these terminologies will be becoming really clear to you, right? So API integration of results is easy, Rohan is saying, which is again a really good answer, right? Sumanta is saying large number of libraries, of course, open source, easy to learn, object-oriented language, right? So we'll dive into this particular aspect of Python as a programming language in the second week when we talk about objects and classes and methods and how they can help make our life easier, right? Right. So easy to learn and implement. Okay, so we have had right. So a lot of answers here, right? So very versatile, large built-in functions. Yeah, someone is Selva is saying just like English language. I would say yeah, it's relatively closer to English, but yeah, it's not. Of course, the rules are a bit different, and yeah, right. So I'm getting a lot of good responses here. So I think you guys can go ahead and yeah, just yeah, delete your just delete your post now, right? So you can. I think I've gotten a lot of responses here. So you guys can just go ahead and delete your post so that yeah, I'll ask you next set of questions and then you can post them here. Okay. So now we know why Python is such an important language to know, right? So we can do a multitude of tasks using Python. Okay. So yeah. All right. So we'll start with the understanding of basic data types which we'll encounter in Python, right? So the first data type is numeric variables. So they take values which are like numbers, 9, 3.14, right? So they can be, uh, right? So real numbers, they can be integers, right? So everything is of course within real numbers. So any sort of number you can conceive of, right? So they can be handled in Python. So those variables will be taking the value and the data type will be numeric, right? So what is a variable? We'll be covering that too. Okay. The another type of data type which we'll encounter in Python is string. So string variables are used to store textual information, right? So if you want to store, you know that nowadays we're generating a huge amount of text, right? So you are, let's say a lot of people are writing, tweeting on Twitter, right? A lot of people are sharing some posts over LinkedIn, or maybe a lot of people are sharing some content over Medium, Quora, or even Facebook, right? So we have a surge of information like text, right? And it becomes pretty important to handle those sort of information. And so string data type are able to store textual information, right? So we'll talk about this tomorrow. Okay. The third data type is Boolean. So Boolean variables have two modes, either true or false, right? So they can only take two set of values, which are true or false, and they are a definitive judge of statement. So we'll be talking about them today. Okay, and then there's another data type which is date time, right? So these variables are used to store date and time values such as right. So 1st of August 2020, and then some particular time, right? So we can have a lot many different formats. So the ones you might have seen in Excel, right? So something like 1st Jan 2020, right? or Jan 10 2021, something like that, right? So we have these basic data types in Python, and of course, even if you talk about other type of data, so for example, you can have images, right? So they can ultimately be boiled down to a bunch of numbers, okay? And of course, the same thing is with audio data as well, right? So we can uh, decompose them into some set of numbers which our computers can process, right? That's the same thing which will happen when we process text. So in machine learning, you learn about that we can create embeddings of words, right? So we can create vectors for a single word, and how those will be done will be discussed when we learn about machine learning, right? So let's not digress much, and get started with the fundamental data types, right? So the first is, so within numeric, we have integers and floats, okay? So you know about integers, right? So integers are the numbers like -2, 0, 1, right? So all those, let's say positive or negative natural numbers, including, and then we have 0 to, right? So that's an integer. Float is again the data type for denoting any real number, right? So it handles the decimals well, okay? So let's just have a look at the basic arithmetic that we can do using uh, so uh, using the format or the facility provided by Python, right? So here I have 2 plus 1, right? So if you can, right? So I'll just run this, okay? So I think a lot of people, if you're not familiar with Google Colab Notebook, so I'll just tell you how to use this. Okay, so you open the notebook, right, with the link which is available in your dashboard. Then you go to File, you save a copy in Drive, right? So if you do this, so it will get saved in a folder in your home drive, right, which is named Colab Notebooks, right? So here it will get saved when you save a copy, and then you can move that file to your respective module, week, and day folder, right? So whatever we have suggested, so that you can do. So if we do 2 plus 1, right? So the answer is 3. We can run this. So 2 minus 5, that is -3. Okay. So this is subtraction, right? And then we can do multiplication. So let's say if I want to multiply 2 and 2, so the product of 2 and 2 is 4, right? So we can have other bunch of numbers, right? So 2 into 4 is 8, right? We can have 4.2, so something like this. So 8.4 is here, and then so these are the basic arithmetic operations, and then we can have a division, right? So if you divide 3 with 2, so it will yield you 1.5. Okay, so so this is these are the basic mathematical operations which you are already aware, right? And then we have something called floor division. So can you tell me, guys, what do you think floor division means, right? So please, yeah, just delete your answers and then post here. Yeah, just whatever the answers you have posted before to the previous question, just delete that, and yeah, just tell me. So what do you think floor division means, right? So I just want a crisp answer from you guys. Okay, so what would floor division give you? So how is it, how do you think it is different from a regular division, right? So instead of the single slash, if you have 2 slashes, right, so what would that imply, right? So uh, okay, so integer value of division, right? So is it the greatest integer less than that value, or the least integer greater than that particular value? So are we taking the ceiling or the floor? Are we taking the ceiling or the floor? Yeah, so I got one answer, that is we will take the floor, right? So 7, if you just simply divide 7 with 2, you'll get 3.5, right? And when we just apply floor division, that means we specify 2 double slashes here. So the greatest integer which is less than or equal to 3.5 is 3, right? So that's the definition of the floor, or the what we also call as floor of x, right? So that is also denoted as, if you remember, So let's say if I have 2.5 here, right? So this is to used to denote the float. So this will be equal to 2. Okay. All right. So and then so I hope floor division is clear to you guys. And then we have exponentiation. So we can also raise a number to a fixed power. So that can be 2 to the power 5. So right. So here instead of single star, we'll have 2 star. That means we'll be raising 2 to the power of 5. Okay. So let's run this cell and see what it gives out. Yeah. So 32. Right. So we can have, let's say, 3 to the power 4, right? So what this will give us 81. Okay, so this is exponentiation. Okay, all right. And then we have another arithmetic operation, which is the modulus operation. So can you again guys tell me if you understand what modulo or modulus operator means? Yeah, yeah, right? So some people are saying remainder, right? Okay, so what do you think 5 mod 3 will give us, right? So the remainder when we divide 5 with 3 is 2. So that is what is yielded by the modulus operator. Okay, and then let's see what's the order of operations which we follow in Python. So these are the basic set of operations which we can do. And so addition is there, subtraction is there, multiplication is there, division is there, then you have floor division, exponentiation, modulus, right? Here let's see if we try to run this particular cell, right? So this is 2 plus 10 into 10 plus 3, right? So this is the order which is which you're already familiar with, and let's see what it gives us. So the bracket should get preference, right? So 10 plus 3 will be evaluated first, so 30, then multiplied by 10, so that is 130, and then we're adding 2 here, so this will give us 132. Okay, so now there's another notation which we can use in Python, so that is the scientific notation. So if we have 4e6, so what do you think it will give us? So 4 into 10 to the power 6, right? So 4e6, this essentially translates to 4 multiplied by 10 to the power 6, right? So 10 to the power 6 I can denote as this one, right? So this is what is denoted by the scientific notation when we write 4e, and in fact you can also write small e, right? So this is again almost what this is. So 4 million, right? So 4 into 10 to the power 6, so 10 to the power 6 is just 1 million, and then you're multiplying it by 4, so that is 4 million, right? So these are the basic set of operations which we can do in Python. Okay, and okay, so now let's talk about numbers, right? So in this lecture we'll be mostly talking about numbers, and then towards the end we'll be talking about Boolean variables, right? So let's talk about numbers first. So a lot many different types of numbers are supported in Python, like integers, real numbers, complex numbers, right? So integers are denoted as int data type, real numbers can be denoted with float data type, and then we have complex numbers, right? So mostly we'll not be using a complex number, but we'll stick ourselves to integer and floating point numbers. Okay, so as you know, integers are just whole numbers, positive or negative, right? So for example, 2 is an integer, minus 2 is an integer, 0 is also an integer, right? And then you have floating point numbers in Python, so they are notable because they have a decimal point in them, or we can also use an exponential to define the number. So for example, 2.0, so when we have decimal places, right, so these will be these numbers or values will fall into the category of float data type. Okay, and then we have minus 2.1, right? So something like this. So these are all examples of floating point numbers. So any real number that you can conceive of will be a float data type, right? So then again, 4e2 is also an example of floating point number, and as you can see here, we have 0.0. That means this is again of float data type, right? So in computing floating point arithmetic is arithmetic using formulaic representation of real numbers as an approximation to support a trade-off between range and precision, right? So let's say if you have a lot of values after decimal, right? So that means you are being a lot precise, but we also need to keep in mind how much range we want to have or accept, right? So we can always control the range and precisions, right? So there is a trade-off between these two. So the more numbers you have after the decimal, right, so it will be more precise, right? So for example, if you know about this quantity mole or Avogadro's constant, right, so you can have 6.023 something like that, right? So you can have a lot of decimal places. So that will depend upon what technology you are using, right? So if your technology is really precise, then it will need to those numbers will have a large number of decimal places, right? So this is what I mean by precision. And of course, you know the range. So let's say you want to stick to the first two decimal places, or the first three or first four, something like that, right? So these are your basic integers and float data points, right? So this is a summary of the two data types, right? So now let's talk about what is a variable, right? So this is a really important concept, and you should uh, be really strong with your concept about a variable, right? So what are variables? So variables are those entities which help us store information, and they help us retrieve it later, right? So we can store some value. So here, if we talk about, so we have not specified or used any variable as such, right? So we're just writing raw numbers there and doing some basic arithmetic operations. But of course, when we talk about data, right, so we need to have a way in which we can store the information in certain variables and pass those variables around here and there, so that we can get our task done, right? So variables are entities which help us store information, and they help us retrieve it later, right? So a variable with a fixed name can store information of nature like numeric, textual, Boolean, etc. Right? So a variable with a fixed name, right? So it can store information of nature like it can be a numeric data, right? It can be textual data, Boolean data, right? So all those sort of data types or the information which we can store in a particular variable. Okay. So a Python variable is a reserved memory location to store values. So in other words, a variable in a Python program gives data to the computer for processing. Okay. Then the type of data contained in a variable can be changed as users will, right? And that's why we have this name variable, right? So let's say if you're storing a particular value in Python in a variable, and that value, let's say, was a number, but later on you can store a text there in by using the same variable, right? So we'll see that now. Okay, so first things first. So the standard rule in Python is that you write the variable name followed by equal to sign and the value it will take. So in this particular example, I have taken x is equal to 5. One important thing, if you want to add comments in your uh, in your collab notebook, right? So even in your Python, so you need to specify hashtag here. Okay, so provide hashtag here, and so whatever you write after the hashtag, so that will be treated as the comment, and that will not be processed or interpreted by Python, right? So this is the beauty of comments here in Python. So you can just provide hash here, and then you can write anything what you want. So these are sort of meant to help you remember, yeah, which code is doing what, right? So of course here we do not have relatively complicated codes, but when we deal with let's say functions or any specific lengthy code, so we'll need to specify what a particular code or statement will do, right? So that we can keep track of using these comments, right? So you can just provide hash, and then you provide whatever that piece of code is doing, right? So a statement in Python is looks something like this, right? So here I have a variable which I'm calling as x, right? So x is my variable name, and then I'm writing equal to, right? So that is the convention which will be which is being followed, and then you provide the value this variable would take, right? So here I'm specifying x is equal to 5. That means the value 5 is being stored in this particular variable x. Okay, so let's run this. Okay, and then okay, so it will run this, and then if you want to see what value x contains, so you can simply write x, and then you can run this cell. So how do you run this cell in Colab, or even if you're using Jupyter Notebook? So a very easy command is to use shift plus enter, right? So if I'm here, I'll just press shift plus enter, and this will run this particular cell, right? So if I want to run any cell in Python, so I'll do shift plus enter. Okay. One more thing you need to keep in mind. So in Colab we have, or even in Jupyter Notebook, so there are two types of cells which we can add. So one is code and another is text, right? So let's say if I click on code, so if you can hover over anywhere, so you'll find an option of adding these two code cells. So let's say if I want to add code, okay. So code cells are meant to write your codes, right? So those are the codes which you can execute, right? So I can write x is equal to 6, okay, and I'll press shift plus enter, right, and this will get executed. Now if I run x again, right, so x will now take a value 6, right? So earlier x was taking the value 5, but I provided here x is equal to 6. So now the value which this variable x contains has now been updated, right? So earlier x was containing the value 5, and but now it's containing the value 6, right? So whatever the information that is stored in a variable can be changed at user's will, right? So that's why we call them variables, right? So they can vary, right? So whatever the information which is storing them, that can vary depending upon our discretion. Okay. All right. So all right. Okay, and then there is another cell which we can use. So as you can see, text, right? So text cell is meant to add some piece of text if you want to do, right? So here I have added a text cell, right? So let's see if I wanted to write something like this. So what I'm doing, so double hashtag. So double hashtag essentially represents which type of header you want to have. So let's say if I have one hash, so this will be a relatively bigger size, right? So if I provide one hash, so the size will come down. If I provide another hash, the size will go down a bit, right? And then you can write whatever you want to here. And so here, of course, I am writing this in a U tag, which is which is just similar to HTML, right? So now you can just simply shift plus enter, and then it will look like this, right? So this is a text cell, right? So this is meant to write any sort of a piece of information which you want to write, right? So the thing is, this is very useful for us, not for only this moment, but for any exercise which we'll be doing later on, because you can write your codes using the code cells, but you can also add the piece of information which you want to add, right, corresponding to that block of code or something like that, right? So this is not only then a code notebook, but it is more or less looks like a blog, right? So you have a bunch of text, and you have a bunch of codes, and much more than that will be, as we'll be saying later on, that we can have interesting plots, bars, and charts, and a very interesting visualizations which we can print, right, or which we can obtain in our Colab notebooks, right? So Colab notebook is really powerful Python environment, and that will definitely help you write a very or create a very comprehensive notebook to study later point of time, right? So we can add code cells, we can add text cells, and then of course as we'll be seeing later on, that we can have interesting charts, animations, plots, etc. Okay, so now so there are a lot of options. So you can move a cell upwards like this, you can move a cell downwards, right, and you can add a comment, something like this, right? You can also delete this particular cell here, right? So there are a bunch of shortcuts which you can resort to. So if you can just click on keyboard shortcuts and tools, right, so you'll get to see a lot of different shortcuts, and of course you can also set your own shortcuts, right? So if you want to, there are a lot of facilities, right? So for example, if you want to add a comment, if you want to add a code cell below, right, you want to run a cell, you want to save a copy in drive, so there are a lot of different functionalities, so you can use these shortcuts. So you'll need to spend a lot of time with this if you want to get your work done quickly. So you can play with a different set of shortcuts and see if that helps you optimize your task. Okay, so these are the basic things, and then of course here there are a lot of things. So here we can also mount our drive. So as of now we'll not be loading any data set, but in future when we feel the need that we want to load a data set, so which we'll be doing by mounting our drive. For now I'll not be discussing this. Okay, now one other important thing, right? So here what we did, so I used two code cells, right? So in this one code cell I wrote x is equal to 6, and then in another code cell I wrote the name of the variable, and then I ran this cell, and this gave me the value which this variable contains, right? We can do both these operations in the same code cell, right? So every line in Python corresponds to a statement, right? So this is one line, then this is another line, right? So in this line we're writing a statement where we're defining a variable. So what is this variable? So here our variable name is y, and we are storing a value 6.4 in this particular variable, right? So 6.4 is a float data type, right? And then I can print what value this y contains by just running this cell. So how do you run the cell? You just do shift plus enter. Okay, now so if I wanted to print what value a particular variable contains, right? So I was just writing the name of the variable here, right? And then it displays me the value it contains, right? There is another way which we can do the same task. So but here we can write a print function, right? So print is an inbuilt function in Python. If you're not familiar with the terminology function, so don't worry about it much, right? So we'll be discussing this later on, but just keep this in mind that a print is a inbuilt Python function, right? So it helps us print whatever we want to, right? So here, let's say if I want to print this variable y, what it means, printing a variable, that means the value which it contains, right? So I can write print, and then I'll write parenthesis, and then in parenthesis I can write the variable name, and I can just run this cell, and this will yeah, so y contains the value 6.4, right? And this it will print 6.4. So let's say if I delete this one, okay, and I set, let's say 6e, which is 6e4, right? So this will be a 60,000. So let's run this cell, okay, and see what y contains, right? So let's print y. So y contains the value 60,000. Okay, so makes sense. Now we can have something like, let's say Avogadro's constant, right? So something like this, and then we can print. So you know that Avogadro's constant is quite a large number, and it doesn't make sense that if you Python, it doesn't make sense for Python to write all or show all the zeros. So instead we can have so it prints 6e plus 23, right? So it is essentially 6 into 10 to the power 23, right? So okay, so students who are part of the premium program, you can use the chat, Zoom chat, to and just ask your questions privately. Okay, so you can ask your questions privately to me, and then people who are yeah, watching this lecture, right, who are not part of the premium program, you can post your questions in the Q&A session section, and I'll take your questions from there. Okay, so all right, so you can post your questions in the Q&A section. Okay, so Saurabh has a question. So how I can execute IPYNB file from a Python terminal which generally executes .py file? Okay, so Saurabh will not be discussing this. Of course, you can pose this question in the discussion forum. See, a lot of people are new to this Python thing, and I don't want to overwhelm you guys with a lot of intricate stuff. So I'll try to keep it simple. And as we progress through the course, we'll only be resorting to Collab notebook. So Collaboratory is a software developed by Google. So here it's a Python environment, or what we also call as IDE, Integrated Development Environment. And here we can do all sorts of experiments we want to do. We can write all sorts of codes here. We can run them, right? So we will not resort to any sort of other IDEs. For now, we'll only be sticking ourselves with the Collab notebook, right? So this is pretty powerful, right? So a lot of libraries are already loaded in the Collab notebook, and then yeah, it gives us a lot of flexibility, right? So you can add some comments, or you can share your files with the other people, right? So there are a lot of advantages of using Google Collab notebook. So for now, we'll not be discussing how to run a Python file from a terminal or any other IDE, such as, let's say, Jupyter notebook, or even your VS Code, or any other such IDE which we want to use, maybe Spider, right? So we'll not be discussing those. We'll only be restricting ourselves to Collab notebooks, because we can get almost all our things done in Collab, right? So there will be no deficit from learning perspective if you're just using Google Collab, right? So of course you can ask those questions in the discussion forum, and I'll take it from there. Okay. So moving ahead, so we can do basic arithmetic operations on let's say two variables which are x and y, right? So earlier when we wanted to just add two numbers, so we're just writing 2 plus 3, right? And then we were getting the answer. But now we want to have a lot more freedom. We want to have a lot more flexibility. So we can store these values in specific variables, and we can add those variables together and store that those operations on the predefined variables in another variable, and we can see what values it contains, right? So here, let's say if I want to do z is equal to x plus y, okay? So here what I'm doing, right? So x contains, so let's print x and y first, and then we'll be able to verify whether the results make sense, right? So x is 6 currently, y is 6 e to the power 23. Of course, let's update this. So y is equal to 6, or maybe let's y is equal to 5, and then I can print what y contains. So it contains the value 5, right? Now, so this is the comment, right? So which is to denote what this block of code is doing, right? Or the statement below it. So we are doing an addition operation here. So here, firstly, we define a variable z, and then of course you are familiar with the equal to sign, right? So whenever we want to assign a value to a variable, we write equal to sign followed by the name of the variable, and then we can write x plus y, right? So instead of writing simply x plus 5, 6 plus 5, we can write x plus y, right? So z now contains the sum of the values contained in these two variables, which are x and y, okay? And then we can print the variable z here, right? So this is 11, right? So you can confirm 6 plus 5 is 11. Now let's say if I change the value of y here, so maybe let's say 8, okay? So y is 8 here, and if I run the cell, so it will be 8 plus 6, which is 14, right? So I hope this makes sense. So can you guys please write over chat if you are able to, if you have been able to understand until this point, right? So what is a variable and how we are storing values in a variable? So you can write, yeah, just write yes privately, and yeah, just chat privately with me, okay? Okay. And people who are not part of the premium program, let's say if we have any other generic doubt which is not specific to this particular lecture, please ask these questions in the Slack channel or ask those questions in the community, right? So we don't want to digress, right? So use the live lectures to ask only very relevant and specific questions pertaining to this topic. Any general discussion or any general query, you can post them in the community or the discussion forum, right? So okay, so everyone has been able to follow me till at this point. Okay, now we want to do the same similar operation. So earlier we were doing addition, now we want to do subtraction. So how we can do that? So z is equal to x minus y, right? So it's very similar to what we have written above. And so let's go ahead and yeah, just print this. So yeah, it gives us -2, right? Because 6 minus 8 will be -2. Okay, let's not discuss about this. Okay, now this another very important important function which we can use in Python to find out what is the data type of a variable, right? So a variable can contain uh, values which can be of very different data types, right? So let's see what is the data type of the variable y. Okay, so I'll just run this cell and it says that yeah, y is equal to, so the type of y, right? So type is the word. So you write type and then in the parenthesis you provide the name of the variable. Okay, so this will give you the data type of the variable. Okay, so okay, now so if I have let's say if I have y is equal to 6.0, right? So this is y and I can move this cell below y. So how can I do this? I can click on this down arrow, right? So now this piece of cell has been put down below this one, right? So now I can check the type of y here, right? So as you already might have guessed, this would be a float data type because we have a decimal here, right? So this is how you can find the type of a variable. So by type I mean the data type. Okay, so all right, okay, so now we can do the same set of things. So let's say if I want to multiply two variables, so we can multiply x and y here. So z will be equal to x star y, and then I can print what is the value contained in this variable z, and then I can also find out the type of this variable, right? So type gives us the data type, right? So you can add the comments here too, right? So the comments are not interpreted by Python, so those things will become clear. What is the meaning of interpreting, right? So those things will become clear. I think we'll be discussing this on Friday. So you need to just curb your curiosity at this moment, and then we'll be taking all these things. But just keep this in mind if you want to find out what is the value a variable contains. So you can use the print statement, or you can simply write the name of the variable. Okay, and then you can find the type of the or the data type of a variable. So you can just write type, and then within the parenthesis you can provide the name of the variable whose data type you want to obtain. Okay, so now let's do the division operation. Okay, so here x is also 6, y is also 6, but y is a float data type, right? So the division will yield a float data type, right? So as we can see here, the type of the variable z is float, right? So as you can see here, z was earlier containing the value 36, but now it contains the value 1, right? So that's the property of a variable. So we can change the value a variable takes, or we can also change the type or the data type of the variable. So up till this point, we have been only dealing with numeric data types or numeric variables, right? But of course, at later point of time, we'll be discussing about strings. We'll be talking about other data types such as list, tuples, dictionaries, etc. So all those things will become clear. Okay. Now we can do the float division too here, right? So what this will give us, right? So this will give us 1, right? So this is the float division. Okay. So maybe let's say if I set x is equal to 3 and y is equal to 4, so I can set x is equal to 3, y is equal to 4, right? So if I want to do the floor division, right? So if you do the normal division, it will give you 0.75, but if you do the floor division, that means you specify the two forward slashes, so it will give us 0, right? So Sheets is asking all code cells of Google Colab are connected same like in Jupyter. So more or less, yeah, they are same, but Colab might have extended functionalities, right? So the idea is more or less the same. So you can think of Google Colab as a Jupyter notebook which is hosted on a cloud or on a server, right? So what is a cloud or what is server? So Google has a lot of big data centers, and they have very large servers, and on all of these servers there are machines, right? So this piece of code is running on a particular machine somewhere in a particular data center in a particular server, right? So a server will have different machines. A machine, by machine I mean a system such as your computer, right? So your computer is also a machine, right? So these codes, when we're running in Colab notebook, so these are being run in a server. But let's say when you're using Jupyter notebook and you're using in the local environment, so whatever you are running, so that you are running on your local machine, that is your own computer, right? So that's the difference between Jupyter and Colab. And right, so it's essentially the same thing, but Colab is Jupyter is running on your local, but Colab is running on a server, right? So Sumanta is asking why we should use print statement if directly calling variables giving the same results. Okay, so I'll get to this point, so you'll get your answer, Sumanta. Okay, so I'll be coming to this particular point. Okay, now let's say y is equal to 5, x is equal to 3, and then I want to do some modulus operation here. So z is equal to y percentage x, and then we can print z here, right? So let's see. So it gives us 2, right? So 5 modulo 3, so the remainder is 2. So that's why if you yeah, just print the value contained in the variable z using this particular statement. So this is 2. Okay, so we can do a bunch of other arithmetic operations that we discussed above. So we can do something like this. So this is exponentiation. So x is 3 and 3 is raised to the power 5, right? So remember, double star will be used for exponentiation. Single star will just multiply those two numbers. But if we have something like x star star y, that means x to the power y, right? So here if you raise 3 to the power of 5, right? So if you raise 3 to the power of 5, that will give you 243, right? So I hope that makes sense. Now, so now what we can do, so earlier our variable names were something like x, y, z, but we can have some other variable names too, right? So something like, let's say, some random operation, right? So this is the name of the variable in which I'm storing the result of this particular operation, right? And so this is the operation which we can of course write, and then you can print what this variable contains, right? So the value it will contain, and then you can find the data type of this particular variable. So let's go ahead and execute this cell by pressing shift plus enter. So some random operation. So this is the variable name, and this contains the value 7.6, and the data type is float, right? So you know already about the float data type. So it has decimals in it. Okay. So now, now let's jump into understanding or familiarizing ourselves with the rules for naming a variable in Python, right? So of course you can come up with all those very unique ideas of naming a particular variable, right? But in Python we need to follow some certain set of rules for naming a variable in Python, right? So the first thing is variable names must start with a letter or an underscore, like underscore product or product underscore, right? So this is very important. So variable names must start with a letter or an underscore. No other character can be used to start the name of a variable, right? So variable names must start with a letter or an underscore, right? So something like this. So underscore product or product underscore, right? It cannot have any other characters for that matter. Okay. Uh, so the second rule is the remainder of your variable name may consist of letters, numbers, and underscores, right? So the remainder of your variable name may consist of letters, numbers, and underscores. So now you know that the name of a variable can only start with a letter or an underscore, but the remainder of your variable name, they can consist of letters, numbers, or underscores, right? So Python does not accept any other character. So maybe if you wanted to use space, that will not uh, be used, or that will be an invalid variable name. Okay, so let's see what are some valid variable names in Python. So spacey one, right? So here let's see if these two rules are satisfied. So the variable name must start with a letter or underscore. So it's starting with a letter, right? There we go. And the remainder of my variable name can consist of letters, numbers, and underscores. So here we have letters or numbers, right? So that's fine. We're not having any other characters. So this is a valid variable name. Then something like Python. So this is also a valid variable name. Then you have machine learning. So here we have underscore, right? So this is again a valid variable name, right? Then the variable names are case sensitive, right? So if I have a variable name case underscore sensitive, all in lower cases, then I have another variable name which is case sensitive, but now every letter here is in uppercase, and something like this, right? So all these three are different variables. Okay, so you need to keep in mind these particular set of rules. I'll reiterate the rules for you again. So the variable names in Python must start with a letter or an underscore. Okay, that's the first rule. The remainder of your variable name may consist of yeah, so they may consist of letters, numbers, and underscore. And then uh, uh, then the names are case sensitive. Okay, so variable names are case sensitive. So whether you write depending upon if you write them in lower cases or upper cases, so those will be different variable names, right? So okay, now let's say if I want to start if I want to write a variable name whose first character starts with a number, right? So do you think this will run or give us an error, right? So this gives an error, right? So it says that it's an invalid syntax, right? What if I just get rid of one, and let's see. So this is a valid variable name, and I can check what O, right? So if you write this ON, Colab will of course suggest you if this variable is already present in the environment. So it already suggests you, yeah, so this this is your variable name. So I can just click on this, and then I can just run this cell by pressing Shift plus Enter, and then this gives me the value this particular variable contains, right? So if what about underscore, right? So do you think this will be a valid variable name? Can you guys tell me over the chat? Do you think this will be a valid variable name, right? So it ran basically. So I can just see what value it contains, right? So it contains the value 4, right? It's a valid variable name. Okay. So now we can write another variable name. So you just need to make sure that you're fulfilling these conditions whenever you're writing a variable name. So make sure whenever you're writing a variable name in Python, they should have numbers, they should have underscores, or they can have numbers, they should have letters, they should have underscore, they should have numbers, and the only requirement that a number cannot be present in the start of your variable name. That means that will be an invalid variable name. Okay, so I hope that makes sense. Okay, so I'm getting some responses, so I think okay. All right. So names cannot begin with a number. Python will throw an error when you try to do so. So we have already seen this. Python indeed throws an error whenever we try to begin the name of a variable with a number. Names cannot contain spaces right? So names cannot contain spaces. This is very important. If you want to have something instead of spaces, so you can write underscore, right? So underscore is accepted. So never use space, otherwise yeah, it will not never be a valid variable name. So names cannot contain spaces. Also, names cannot contain any of these symbols, right? So like colon, uh, single quote, double quote, comma, right? Less than, greater than, then slash, question mark, pipe operator, then forward slash, and then exclamation mark, at the rate, hashtag, percentage, exponent, ampersand, star, tilde, minus, positive, right, minus, plus. So all these symbols, they cannot be used in a variable name, right? So you need to keep this in mind, right? Another important thing is it is considered best practice that names are lowercase with underscores, right? So names should be in lower case. Of course, you know that variable names are case sensitive, and it's for the best practice. You should follow that. Yeah, whenever you're writing a variable name, write them in lower cases, right? So, and then avoid using Python built-in keywords like list, str, def. So there are a bunch of built-in or reserved keywords in Python, which we should not use to write the name of a variable. So even though if I write list is equal to 5, right? So if I write list is equal to 5, so it works, right? But of course, list is a reserved keyword in Python, and as you can see the difference here, right? So it's sort of appearing in green here as opposed to the black here, black font. Okay, so the reserved keywords, they come with their own color. Okay, and you'll be able to identify whether a particular variable is a reserved keyword or not. Even though this works, will you try to use the best practices going forward. So we'll avoid at any cost to use the inbuilt Python keywords such as list, str, df. Now you'll ask me whether what are all the sets of built-in keywords. So you don't have to bother about that at this moment. But what you can do as we move ahead over the course of next few days, you'll be able to acquaint yourself with different built-in keywords in Python. Okay, so that you don't have to worry about. Okay, now, so up till now we have been able to cover the basic numeric data types, right? So we have integers and float data types within the numeric one, and then we saw how we can define a variable, how we can store a value in a variable, and then we looked at the rules for nomenclature of a variable, right? So what rules you should follow strictly whenever you are naming a variable in Python, right? So those things you need to make sure you're adhering strictly, right? Otherwise you will often more often than not you will be running into errors. And so the earlier you adopt the best practices, the better you will become, and the better you will become at programming in Python. Okay, so now let's talk about another data type apart from the numeric. So these are Boolean variables. Okay, so a Boolean variable, as I have already mentioned to you when we started the lecture, that a Boolean variable only takes two values, either true or false, right? So these variables, they're used for comparisons. Okay, so they're used for comparison, or they are closely related to what we call comparison operators, right? So let's have a look at various comparison operators. So firstly, these operators will allow us to compare variables and output a Boolean value, right? So what are the two Boolean values which we can which we have? So they are either true or false. Okay, so you might remember these things if you have learned about Boolean algebra, or if you have had any class, let's say even in your 11th and 12th, where you learned about logic, right? So Boolean variables are named after a famous British mathematician, George Boole, and it's a really helpful concept, right? Whenever we are talking about logic theory. So here, Boolean variables are used for comparisons, right? Now, so these are the set of operators which are also called comparison operators. Then there you have double equal to, right? So if the values of two operands are equal, then the condition becomes true. So if I have something like A equals to B, right? So this is a comparison operator. So this will compare A and B, and it can either return true or false. So if A and B are both equal, right? So that will return true, else it will return false. First of all, you don't have to get confused with a single equal to and double equal to. Single equal to helps you define the help you define the value or store the value in a particular variable, right? But double equals to, it's a comparison operator, right? So if the values of the two operands are equal, then the condition will become true, or else it will be false. We then have not equal to, so this is read as not equal to, right? So we have exclamation and then equal to, right? So this is said as not equal to, right? So if the values of the two operands are not equal, then this condition becomes true, right? So let's say if A is 4, so in this example A is 3 and B is 4, right? So A equals to B, that means 3 equals to 4, right? So it will do the comparison of both the values, and we know that 3 is not equal to 4, so this will yield not true or false, right? So this is not true. Then we have A not equal to B, right? So not equal to means that this is not equal to, right? So 3 is not equal to 4. So what's the result of this particular operation or comparison? It is true, okay, because A is not equal to B. Okay, then we have other operators such as greater than. So here let's say A is greater than B, right? So here if you take the example, so 3 is greater than 4, right? Which is definitely not the case, right? So this will yield not this will yield false. Okay, then we have less than equal to, so A less than B. So of course we'll be running few codes to demonstrate how comparison operators work. Then you have greater than equal to, right? So A greater than equal to B, if this condition is satisfied, then it will return true. But in our case 3 greater than equal to 4, that's not true, so it will return us false. Okay, similarly we have less than equal to. So Python comes with booleans with predefined true and false values that are basically just the integers 1 and 0. It also has a placeholder object called none. Okay, so of course we'll be talking about the none thing later on, but as of now let's acquaint ourselves with these two keywords, which are true and false, right? So firstly I am writing a variable name, right? So this is a valid variable name, right? It starts with a letter, and then all the remainder of the characters or the here are either letters or underscore, right? So it's a valid variable name. So the name of my variable here is Boolean underscore variable, and I'm storing a value in this particular variable, and I'm writing false, right? So false is a word or a keyword recognized by Python. So if you write false in this way, so it will understand that it's a Boolean value which is false. So if I just run this particular cell and print the type of this particular variable, so it will return bool, which is short for Boolean. Okay. Now I also want to, let's say, see what value this Boolean variable contains. So I can write Boolean variable here, right? So it contains the value of false. I can also write print, right? So I can also write print. Okay. So false is it contains the value false. Okay. Now let's have a look at all these comparison operators. So 2 equals to 3, right? So this will return false, right? So there's a comparison going on here. So 2 equals to 3, right? So of course 2 is not equal to 3, so this will return false. 2 equals to 2, right? So what this will return? This will return true, because 2 is of course equal to 2, right? So just keep this in mind. I am reiterating this. So double equals to is a comparison operator, while single equal to is an assignment operator, right? So whenever we wrote something like this, right? So this is an assignment operation, as in we are assigning a value to a variable. Okay, so keep this in mind, don't get confused. So double equals to refers to the comparison operator, while the single equals to refers to an assignment operator, right? Okay, so now let's look at not equal to. So 2 not equal to 0, which is in fact the correct, right? So this will return true. 2 not equal to 2, right? So of course 2 is equal to 2, so it will return false. So I hope you guys are following along. Can you please let me know if you are able to understand the concept of Boolean variables? Yeah. So yeah, just everyone, yeah, please ping as soon as possible, right? So you're able to understand uh, what a Boolean variable is, right? So okay, that's great. So all right. So now let's say if I create a variable a and assign a value 3 to this variable, so of course we're using a single equal to, and then in another variable b, uh, we are assigning a value 2 to this particular variable which we call as b, right? And a greater than b, right? So 3 greater than 2, so this will evaluate to true, right? So this makes sense. And then a equals to 3, this will again of course return true. B greater than 4, so B contains the value 2, so 2 greater than false 4, so of course this will evaluate to false. Okay, so similarly we can play around with a bunch of all the other comparison operators, right? So there was one question which was asked by Sumanta. So let's say if we can just write the name of a variable, so why use the print statement? So let's say a is equal to 2, a is so I'm writing a. So what this will do, this will print the value which a contains. Now let's say below a I write print a, right? So ideally you would expect that a will be printed twice, right? So from here and then from here, but here we can see that it's only been printed once, right? So uh, the best, let's try to stick ourselves to the best practices. So whenever you want to print the value of a variable or want to see what a value a particular variable contains, always use the print statement. Of course this is a shortcut that I can write the name of the variable and get the corresponding output or the value it contains. But going forward, let's stick to the best practices possible. So whenever you want to see what value a particular variable contains, so you need to use the print statement, right? So try avoiding just writing the name of a variable. Always use the print statement. Okay. Okay. So always try to stick to this particular concept. And yeah, so I hope you guys have been able to understand whatever has been taught today.